Okay, after you've had a chance to discuss this in your small groups, then we're going to talk a little bit about what ozone is, and I'm going to come back to this picture, and we will try to answer some of these questions. Okay. So first of all, what is ozone? Okay, we think we've already identified that ozone is an allotrope of oxygen. Okay, ozone, of course, is an element, as is oxygen. We call oxygen a diatomic element, and it just so happens that ozone is a triatomic element. Triatomic molecule, I should say. Diatomic molecule, which is an element. Triatomic molecule, which is an element. You know, some elements exist as single atoms in nature, but oxygen is one of those 7 elements that exists as a diatomic molecule in nature, but it also will exist as a triatomic molecule. They are different, even though they're just made of the same atom, oxygen. They have different chemical and physical properties. For example, oxygen is odorless, whereas ozone has a pungent odor. Once you've smelled it and it's been identified, you would always recognize it again. If you've ever spent a lot of time around a laser printer, laser printers give off ozone, and it's that kind of sharp odor that's associated with a lot of printing. And the human nose can detect the presence of ozone at a level of 10 parts per billion. That's very, very low concentration, but our nose sensors are that sensitive to the smell of ozone. Also, ozone, it liquefies at negative 112 degrees Celsius, whereas oxygen liquefies at negative 183 degrees Celsius. Okay, you have to get oxygen colder to get it into the liquid form than ozone. Also, relatively speaking, ozone is less chemically stable. So these are all physical properties, and chemically, the ozone is less stable. That means it reacts more readily. It will react with carbon faster than oxygen. To get oxygen reacting with carbon, you have to add a lot of heat, to start burning oxygen, but ozone will react at room temperature with carbon compounds and other compounds as well. So it reacts, it's less stable, so that means it reacts quicker and at lower temperatures with other molecules. All right, so that's what ozone is. It is an allotrope of oxygen, and allotropes, like for example, these two allotropes are both gases, but they do have different chemical and physical properties, not unlike diamond and graphite. Diamond and graphite are also allotropes of the element carbon, but they have very different chemical and physical properties. As you must be aware that diamond is a good insulator, whereas graphite's a good conductor, and diamonds are clear crystals, whereas graphite is a black kind of flaky substance. Okay, so there are other examples of allotropes, but today we're talking about ozone and oxygen.